2.5, transformations of functions preparation. All right, so use the graph of f of x is equal to x cubed to obtain the graph of g of x is equal to parenthesis negative x in parenthesis cubed. So we're back to an odd one. Okay, so first let's graph the parent function. All right, so it starts in the middle right here. We end up with -1, -1, and a +1, +1. And we also end up with a -2, -8, and a +2, +8 right there. And this should look something like this, but better. Hopefully yours looks better than this. Okay, so let's see what happens. Now, theoretically, it should make it's symmetrical with respect to the y's here, so it should be flipping across this axis right here. This up and down should be that. And let's get some points. So when we say -2 cubed, or a -2 is +2, top +2 cubed is 8. Okay. Then we say -1, which is +1. +1 cubed is 1. 0 cubed is 0. -1 cubed is -1. And -2 cubed is -8. All right, here we go. So we say, we start plotting some of these points. So we still start in the middle. We got the 0, 0. We have -1, 1, which is right here. But we also have 1, -1, which is here. We also have -2, +8, which is way up here. But we also have -2, or I'm sorry, +2, -8, which is way down here. And if we draw it roughly, it should look something like this, which, sure enough, it looks like it was reflected across the y-axis. So, looks good. That's what we expected, right? And again, that's an odd one, so that one was reflected. Now, what about a square root? So we're going to deal with, use the graph of f of x is equal to square root of x to obtain the graph of g of x is equal to the square root of -x. Okay, so this one's going to be a little different. So the parent one, I'm just going to plot these points and draw that out. So we have a 0, we have a 1, 1, we have a 4, 2, oops, 4, 2, and we have a 3, we have a 9, 3, a 9, 3, which would be right there. So if I draw a line through it, it should look roughly something like that, right there. Okay, now, because I have that negative in there, theoretically, if possible, it should reflect right across this y-axis right here. So that's what it should flip around, right? And this is the y-axis, right? Okay, well, let's try it out. So we have 0. Let me plug some negatives in. Fix this. So we have 0. -0 is still 0. Square root of 0 is 0. -1 is a +1. Square root of +1 is 1. -4 is a +4. Square root of that is a 2. -9 is a +9. Square root of +9 is a 3. Okay. So what we end up with is a point here. We end up with a point here. And we end up with a point here. And we just do this. Okay. And there we go. And sure enough, it did reflect. Now, the reason I can't do put a +1 in there, because if I put a +1 in for x, it turns into a -1. The square root of a -1 that's an imaginary number. That's not a real number. Okay? So I couldn't do that. So this had to have limitations, just like the original one had limitations where I couldn't plug in a -x, because that would make it an imaginary number. Use the graph of f of x is equal to the cube root of x to obtain the graph of g of x is equal to the cube root of -x. Okay, so first let's graph our parent function. So we say -8, -2. So there's -8, -2 would be down here somewhere. -1, -1. Then we would have our 0, 0. And we would have our 1, 1, which is right there. We would have our 8, 2, which is right there. So it should look something like this, and then like this. Okay. Now, theoretically, if you plug this negative in, it should flip it along the y-axis, which is right here. So y-axis. And let's see what happens. So we plug in a -0, which is still 0. Cube root of 0 is 0. We plug in a 1, which turns into a -1. Cube root of -1 is -1. We plug in an 8, which is now a negative 8. Cube root of negative 8 is negative 2. We plug in a 9, which turns into a negative 9. Oops. I messed up again. Sorry. That should have been a 27. That wouldn't fit anyway, so we'll just ignore that one. Okay. That gave me let's do a negative 1. If I plug in a negative 1, it turns into a negative 1, which is a positive 1. Cube root of positive 1 is 1. And if I plug in a negative 8, like this, then it would turn into a positive 8, and cube root of positive 8 is positive 2. So let's see if that worked. So we have 0, 0, which is right here in the middle. We have a 1, negative 1, 1, negative 1, which is down here. We have 8, negative 2, which is way over here. We have negative 1, 1. So negative 1, positive 1, which is right here. We have negative 8, positive 2, which is right there. And sure enough, it did reflect it across the y-axis. Okay, let's try another one. So use the graph of f of x is equal to absolute value of x to graph g of x, which is equal to the absolute value of negative x. Okay, so here we go. Whether I plug in a negative or a positive 3, it's still going to spit out a positive 3. Plug in a negative or positive 2, it's still going to spit out a positive 2 because the absolute value of both 2 and negative 2 is 2. And if I plug in a negative or positive 1, again, it's going to spit out a positive 1 because whether it be the absolute value of negative 1 or the absolute value of positive 1, the answer is still 1. And we have a 0. Okay, so let me first graph the original. The base function looks something like this. Okay, and it looks like we plotted that point, that point, that point, that point, and that point. Okay, so let's see whether or not this flips it across the y-axis, which is what it should do, right? This axis right there. And that's the y-axis. Okay, so theoretically, if I plug in a 0, I get a 0, so plug it right there. Then a negative or positive 1 gives me a 1, which is right there and there. Plug in a negative or positive 2, it gives me a 2, right there and right there. And it would just continue on like that, which means that, yeah, it did. It did actually do that. So it looks like it flipped it across the y-axis successfully. Good. All right, so you can kind of imagine these would flip places and it would just look identical regardless, right? Just like that. 2.5, transformations of functions preparation. Use the graph of f of x is equal to the absolute value of x to obtain the graph of g of x is equal to absolute value of x minus 3. Okay, so we're going to start with the parent function, so I'm going to graph this first. So it looks like we have a point in the middle, 0, 0, here, here, and here, and we also have a point here, here, and here. So we just draw it right out, and then right this way. All right. Okay, so let's plug it in. Now, this should have a minus 3 at the end, so that's a typo. Okay, so we plug in a 3. The absolute value of 3, whether it be positive or negative 3, is a positive 3. But then since I'm subtracting 3 from it, I get a 0. The absolute value of whether a negative or positive 2 is a 2. And then I subtract 3 from it, which gives me a negative 1. The absolute value of whether it be a positive or negative 1 is still a positive 1. Positive 1 minus 3 is a negative 2. Absolute value of 0 is 0. 0 minus 3 is negative 3. All right, so let's try this. So it looks like we have both whether you plug in a positive or negative 3, you get a, let's start at 0. So 0 gives you a negative 3, so 0. And then we have, got the right color here, yes. So 0 gives me a negative 3, which is right there. And then I have a plus or minus 1 will give me a negative 2, which is there and there. Plus or minus the 2 will give me a negative 1, which is right here and right here. And then the 3 plus or minus 3 will give me a 0, which is either there or there. And then we draw a line through it. There. And there. There we go. Now notice what happened is when I subtracted 3 here, it subtracted 3 from this, which is really the y's, right? So all the y values went down 3. So I just shifted the entire equation down 3. That's what happened there, right? Okay, let's try another one. So now we're using the graph of f of x is equal to x squared to obtain the graph of g of x is equal to parenthesis x minus 1 in parentheses squared. Okay, so first we draw the original equation. So we just plot these points right here. All right, so we have a point here, 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 and finally there and there. Okay, so we draw a line through all these, and whoops, and we draw a line through all these, and there we go. Okay, so that was the original. Let's see what happens with the transformation. And this should have, whoops, this is a typo. So this really should be x minus 1 squared. There we go. Okay, so what we need to do now is we would write, if I plug in a -2, -2 minus 3 is going to give me a, let me actually write this out. Yeah, let me write that out. So if I say f of -2, that would give me -2 minus 1 squared. -2 minus 1 is -3, so -3 squared is positive 9. Right? And then let's say I do over here. And I say, well, what about positive 2? So then I would say 2 minus 1 squared. 2 minus 1 is 1. 1 squared is 1. Right? So I have to break this apart. So this is not going to work. So I'll do negative first. And then I'll do the positives over here. And that will fix it. There we go. Okay, so for the -2, which is I did over here, that spit out a positive 9. Whereas for the positive 2, it looked like that spit out a 1. Okay, so let's try the -1. So we do f of -1. So we say -1 minus 1 is -2. And -2 squared is a positive 4. Okay, what about f of positive 1? Well, positive 1 minus 1 is 0, and 0 squared is 0. So that should give you a 0. And what about 0? Well, 0. Well, you would say 0, whoops, 0 minus 1 squared. 0 minus 1 is minus 1 or -1. -1 squared is a positive 1. Okay, so let's see what happens with this one. Okay, so we say -2, 9. So -2, 9 is right here. Then we would say and -1, 4. -1, 4 is right here. We would say 0 is 1. Right there. We would say 1 is 0. Right there. We would say 2 is 1. Right there. And if we continued, we would have gotten the rest of these points as well. And when we draw a line through all these, we get roughly the shape of this right here. Okay. Now, as you can see, what happened is it shifted my original graph to the right one place. And that's not an accident. Whenever you manipulate the x within these parentheses right here, this x, this -1 right there, but it has the opposite looking effect. So you might suspect that subtracting 1 would make it go to the left, but in fact it makes it go to the right. And kind of a rough way of thinking of that is I'm going to have 1 less than I think I will for the same height, which is kind of a rough way of thinking about it, right? So for me to get a 0, for me to get a 0 in within 0 squared, right? I need to have a positive 1. I need to have 1 more. So I need 1 more to get the same y result, right? So again, so if I plug a positive 1 in there, -1, that gives me a 0. I have to put a positive 1 to get a 0. And sure enough, 0 squared is 0. That's how I got this point. And for me to get the next one, I have to put a positive 2 in there to get a 1. So I have to put 1 more. Because I'm subtracting, I need to put 1 more in there.